string is one of the most essential data structure in Rust, and sometimes confusing. And trust me, if you've worked with strings in other languages like Python, JavaScript, or C++, Rust's take might feel a little different. But once you get the hang of it, you'll appreciate how safe and powerful it actually is. So let's clear the fog around string and string slice, understand how string manipulation works, explore the methods Rust provides, and finally, yes, we'll talk about Unicode, because strings in Rust are UTF-8 encoded. Let's jump into some code. Let's start with the two main string types in Rust. So here, S1 is a string, and S2 is &str, or a string slice. Now here's the deal. String is an owned string. That means it's stored on the heap and can be modified. On the other hand, &str is an immutable reference to a string, usually hard-coded or borrowed, also known as a string slice. It's basically a view into a string. Let me show you what I mean by mutable. So, name here is mutable, and we used push to add a single character, and push str to append an entire string slice. Let's try that with a string slice. We are getting the compilation error. Why? Because greeting is a string slice, and you can't mutate string slices. They are immutable views. Let's take a closer look at some super useful string methods available on string. Here's how we can concatenate strings. Notice something? We had to use a reference to name instead of just name. That's because the plus operator takes ownership of the first string, hello, and borrows the second, reference to name. That's why you can't reuse hello after this line. It's moved. Want to avoid that weird ownership thing? Use format. The best part, all of those variables, first, second, and third, are still usable after the format call. That's because format doesn't take ownership. It just creates a new string. Now let's talk indexing, or should I say, the lack of it in Rust strings. Try this. Rust strings don't support indexing like arrays or vectors. Why? Because strings are UTF-8 encoded, and characters can be multiple bytes long. That means S0 isn't guaranteed to point to a single character. It might be pointing to a byte in the middle of a character. Instead, we can slice safely. Why 0 to 4 and not 0 to 2? Because each of those Cyrillic characters takes 2 bytes in UTF-8. Rust is strict about slicing on valid UTF-8 character boundaries. Now let's loop through characters and bytes. The chars function gives you actual characters, graphemes, while bytes function gives you the raw UTF-8 encoded bytes. If you're doing text processing, use chars function. If you're working with encodings or performance-critical code, bytes function might be what you need. Let's look at some more string methods. You'll probably use these methods all the time, especially replace, contains, and split white space. Very handy for parsing or manipulating input. Let's talk a little more about Unicode. Rust strings are UTF-8 encoded by default, which means you can store emojis, Japanese characters, Arabic, Devanagari, pretty much anything. Each emoji is a multi-byte UTF-8 character, and Rust handles them gracefully. Finally, a cool little challenge. Try this. We reverse the string by converting it into characters, reversing the iterator, and then collecting it back into a string. That's expressive and safe, thanks to Rust's iterators and type system. Now here is a quick challenge for you. Write a Rust program that takes a string as input from the user and checks if the string is a palindrome, reads the same forwards and backward, ignoring case and non-alphanumeric characters. In Rust, string is your go-to for owned, mutable text. String slice is perfect when you just need to read or reference a string. Together, they give you a lot of control, with zero-cost safety.